Welcome. Welcome to today's questions of the day. And today we're gonna do again some problems on trigonometry, the questions of the day. And I encourage you to pause the video and try those problems one over first. And then if you're not able to do, then watch the solution. If you're able to do it, then again also watch the solution to make sure the method which I do, whether they are different or the same. Okay? To learn new things. Number one problem of questions of the day is that 2 cosine theta. We're going to have lots of square roots now. Okay? Square root of 2 plus square root of 2 plus square root 2 plus square root. So 1, 2, 3, and 4th we have 2 plus 2 cosine 16 theta. Let me just make sure. 1, 2, 3, 4. Yeah, there are 4 square roots. Alright, so how do you solve this problem? So we have to have this become solvable such that this you can solve it through the square root. Okay? So how can I do that? We're going to make something familiar so that we can solve it using the square root, and you can go from there to somewhere else. How do you do this? It's simple. We're going to write. Okay. So I'll tell you first what we're going to do. So this can be written as, you can write this as 2 times 2 cosine square theta minus 1. Why did I choose this formula? Because I want to get rid of this 2. Okay? If I had chosen this, then it's theta here. If I had chosen this, okay, then this comes, okay, this is 16, so this should be 18. If I had chosen this, then 2 comes at the front, which I don't want. I want to subtract 2. That's why I'm going to use this formula. Alright? So furthermore, how's the problem? How's the problem? Okay, so we're going to apply that. This will become square root of 2 plus square root, second square root, 2 plus the third square root, 2 plus the fourth square root. We have 2 plus 2 cosine 16 theta, so we can write this as 2 plus 2 cosine. First I try it on your own, okay? 2 cosine 16 theta, I can write this as 2 times 2 cosine squared e theta minus 1. Does this make sense? So this becomes now. So why did I do this? To get rid of this 2 and to also solve it. This will be square root again. So 1, 2, 3, and 4th square root. Okay. This might be a weird kind of problem. Okay. We have 2, and then this. Okay. So let's do it 2 direct. So because we want to save space. Then this will be 4 cosine square e theta. Why? Because there will be a minus 2 term, and this will cancel this out. The plus 2. We're gonna have left this thing, okay, remaining. So this becomes, okay. So we have 2 plus square root of 2 plus square root 2 plus. I can write this further as 2 cosine e theta. We're going to use the same tactic here for this, okay, for this as well, for this term as well, under the square root sign, under the last square root. Okay, so this becomes a square root. Okay, I think I need to have the square root above. Like that. Square root 2 plus square root of 2 plus square root. And again, this can be written as 2 plus 2 times cosine 2. 2 above, in the front. So 2 should be in the front. So 2 cosine squared 4 theta minus 1. 2 cosine squared 4 theta minus 1. Now, furthermore, okay, I'm going to write this out first. I'm going to show you what's next. can do is, this will be square root. So I took the RHS to solve it, and we're going to prove the LHS. Okay, for this problem, which I mentioned quite lately. Okay? This becomes square root of 2 plus square root of 2 plus square root. Okay, wait a minute. Okay, so 1, 2, 3, 1, 2, 3, and this becomes 4 cosine square 4 theta, and then this will cancel out. So 4 cosine square 4 theta. The 2's cancel out. This plus 2 and the minus 2, because 2 times 1 minus 2, they will cancel out, just like we had done earlier. Now this is going to be square root of 2 plus square root of 2 plus 2 cosine 4 theta. Okay, so this root, now you can see they are disappearing. Okay, they are disappearing now. So further we can write this down as a square root of 2 plus square root. I can write this under the second square root as again 2 plus 2 cosine square 2 theta minus 1, and again the same step, 2 plus the square root of 2 plus, this is going to be, okay, so just write this quickly. I don't know, release the space. So 2 to cancel out, so you're going to have left here 4 cosine square 2 theta. So this becomes square root 2 plus this thing becomes 2 cosine 2 theta. So now you can see that becoming familiar, it doesn't look like as this, but it is getting smaller indeed. So yeah, this becomes square root 2 plus 2 times cosine 2 theta is the same thing as 2 cosine square theta minus 1. Now this will be square root of, okay, 2 will cancel out, so you're going to have 4 cosine square theta, and this becomes 2 cosine theta. And as you can see, this is a very simple problem. The tactic is to make it smaller to solve it, and to solve it use the formula of cosine 2 theta. So when you see cosine 16 theta, write cosine 16 theta as 2 cosine squared 8 theta minus 1, and then go from there, and yeah, that's the ladder. You go down like that, and then you can have the thing that we wanted to prove at the end, 2 cosine theta. Prove it. So we have this thing, move any unit. Okay, so the next problem in our problem set of questions of the day is this. How do we go about proving this, doing this problem? It might be scary, but it's not that hard, and it's also not that simple as well. So how do you prove it? It's the cube term here, but we have to get rid of the cube term. So what do? Okay, so let me show you what you do. First of all, you just distribute the 4 into this, so this becomes 4 cosine cubed 20 degrees plus 4 cosine cubed 40 degrees. And then the next step is replace this thing with cosines only, but the equality should be matched. Okay, write this. So what I'm saying is write this thing in terms of cosine, not in terms of cosine cubed. So what I'm saying is that use the formula of cosine 3 theta, because the formula of cosine 3 theta is 4 cosine cubed theta minus 3 cosine theta. So you have 4 cosine cubed theta right here. So it means 4 cosine cubed theta, 4 cosine cubed theta is equal to cosine 3 theta plus 3 cosine theta. So I want you to use this fact. That 4 cosine cubed theta is equal to cosine 3 theta plus 3 cosine theta. If you use in terms of you want to write it in terms of cosine only, not the cube, then we can use this. So cosine cube 20 becomes cosine 3 theta, which is going to be in this case 16, plus 3 cosine 20. It's easy. So plus, now we're going to do the same thing, 4 cosine 40 degrees. Alright, I'm going to replace 4 cosine cubed 40 with the same formula here. So you're going to have cosine 120 degrees, because 40 times 3, and plus 3 cosine 40 degrees. Okay, we're going to have this thing now, and this thing is solvable because this part and this part, we know in terms of numbers what they are. So we have this thing written in purely in terms of 20s and 40s now. You can see ahead of time. What is cosine 60? That's half 3 cosine 20 degrees. What is cosine 120? That is minus sine 30, which is minus half plus 3 cosine 40 degrees. Minus half plus half, they cancel out. We're going to have 3 cosine 20 plus 3 cosine 40 degrees. If we have 3 common, we're going to have same thing that is there.
3 for cosine 20
plus cosine. And this is all that we wanted to prove. So you have this proven here as well. Let's go to the next problem. But before that, if you want to note this down, first I hope, I mean not I hope, I do think that you might have given it a try on your own first, given it a try. And if you couldn't, then we have the solution now, so you can copy. Okay, next up we have this problem to solve. How do we solve this? Try to learn one first, and then watch the solution part. Okay, so I guess I have to think a little too. So give me a second. Okay, I have thought now. Continue. So this is, okay, let's solve the LHS. So solving the LHS, 1 over, I'm going to write the first term as it is verbatim. And this will become minus 1 over tan 3 theta. You want to write this in terms of tan, in terms of tangent. This will be 1 over tan theta. Now this is going to be equal to 1 over tan 3 theta minus tan theta minus 1 over, this is going to be tan theta minus tan 3 theta divided by tan 3 theta times tan theta. It's going to be this, and this becomes equal to 1 over tan 3 theta minus tan theta minus tan 3 theta tan theta divided by tan theta minus tan d theta. Alright. Now what else do you want to do? And this is tan 3 theta minus tan theta. You want to write this in the same order. So what I'm going to do next is I'm going to write this now. Okay. First this will be same. No change. So this time I'm going to I'm stuttering a lot. I can have now minus common here. So if I have minus common, the signs will be switched. The signs will be changed. And this minus, and if I have the minus common, it will make a plus sign. And this will be tan 3 theta tan theta divided by tan 3 theta minus tan theta. Now at the bottom. So now you can solve this. Okay, this is pretty easy to solve now from this step. Okay, so pause this video. If you want to note this down, then note it down. But now it's time to write it up. Alright. So what's going to be here? Okay, so there's one there. I don't know what it is. This step also needs to be wiped up. Alright. this can be written as 1 plus tan 3 theta tan theta divided by tan 3 theta minus tan theta minus tan. Okay, this will be equal to, now this looks familiar, this looks familiar as tan a minus b formula, tan a minus b formula, but swapped, this is swapped. So what you're going to do is we're going to write this as 1 over, we're going to make it look like tan a minus b formula, tan 3 theta minus tan theta divided by becomes as 1 plus tan 3 theta tan theta, and this can be written as now 1 over, it's the same thing as tan, the formula of tan a minus b, so I can write this as tan 3 theta minus theta, tan 3 theta minus theta, which is equal to 1 over, this is tan 2 theta. In other words, this is cotangent 2 theta. And this is what we wanted to prove. So here we have the thing that we wanted to prove it. Okay? So what was the technique to solve this one? To solve this problem? The technique was pretty simple. Change this into tangent, then solve it. Have minus sign common here such that this becomes plus. Okay, so the denominators, they become equal, and they have the same, and they become equal. Okay.